Okay, I'd like to move on the next session. Focal points to assess vulnerability of coastal protection structure. I'd like to explain the procedures of vulnerability assessment of coastal protection structure. The slide shows overview of vulnerability assessment of coastal protection structure. The procedure has 3 steps. Step 1 includes 3 items. One is assess the past and present climate trends and risks. The second one is to assess future exposure to climate hazard and perturbations. The third one is to assess future sensitivity to climate change. The second step is to determine the project adaptive capacity to climate change, including 2 sub-items: identification of adaptive capacity and clarify exacerbating factors for climate change impact. Finally, step 3 is to assess vulnerability. Okay, now I would like to explain the step 1 in detail. The first step is to assess past and present climate trends and risks. To correct past marine weather records such as tide level, wave, storm surge, and high waves in and around the target coastal area from marine weather stations and regulatory agencies. The second one is to assess future exposure to climate hazard and perturbations. 2A is to study future weather conditions. It is to review the national policies related to climate change and discuss and conform with the counterparts organization that apply climate change scenarios and analysis model and the target year for adaptation measures, and also to estimate marine and meteorological weather aspect for the target year based on the analysis result on climate change. So 2B is to study other factors related to socioeconomic changes. This is to study change factors for land use in the target area which affect the inundation, coastal erosion, storm surge, and high wave damage, sediment load, and littoral drift, such as population change and industrial development through review the national and regional development plan and land use regulations. The third step in step 1 is to assess future sensitivity to climate change. 3A is to study past damage. We have to study the records on inundation, coastal erosion, storm surge, and high wave damage, such as observed record aerial photo and topographic surveys through collection and hearing investigation among stakeholders, such as the related agency and inhabitants, as well as through website on meteorology. We also have to organize the areas vulnerable to inundation, coastal erosion, storm surge, and high wave damage in the target coastal area. So 3B is to study present condition of facility and measures. As for condition of facilities, we have to assess the present conditions of facility based on the design condition, bearing capacity, and the maintenance condition through inventory surveys and review of documents such as reports and drawings for coastal structures in the target coastal area. As for operating functioning condition of facilities, we also have to assess the operational condition of the facilities such as flood gate and drainage pumping station through investigation on operation and management records of facilities, as well as through interviews among stakeholders. The 3C in step 1 is to assess future sensitivity to climate change. We have to study the submarine and coastal topographic features, coastal characteristics such as wave flow and longshore sediment transport and coastal vegetation of the target coastal area. And then we have to assess the future sensitivity of coastal area to inundation, coastal erosion, and storm surge and high wave damage based on the relationship between past disaster and oceanographic and meteorological conditions, future climate risk, and marine condition and the condition of facilities with consideration of future socioeconomic change factors. Here is an example of the inundation area. Left figure shows the coastal flooding with present climate condition, and the right figure shows the coastal flooding with future climate condition. As you can see, the inundation area will increase with future climate conditions. Here is step 2 in vulnerability assessment for coastal protection structure. The fourth step is determine and project adaptive capacity to climate change. 4A is identification of adaptive capacity. We have three small terms. First is community-based disaster management and crisis management. We have to assess the responsiveness against storm surge and high wave occurrence, situations of non-structural measures such as hazard map, warning systems, and evacuation drills, which are related to responsiveness of the local government and inhabitants. We also cover the maintenance conditions of roads and shelters which can facilitate evacuation during disaster. The second point is disaster resilience capacity of regulatory agency. We have to assess the condition of budget and the program of activity for disaster recovery for regulatory agencies. The third point is existing and ability of research and development. We also have to assess condition of research and development for coastal protections. The fourth items in the 4A is compensation for storm surge and high wave damage. So we have to assess the post-disaster restoration capability, like situations of available insurance or mutual aid system for storm surge and high wave damage. The 4B is to clarify exacerbating factors for climate change impact, like land use and land use regulations. So 4C is to clarify the land use and related regulatory policies which affect the inundation, coastal erosion, and storm surge and high wave damages. Finally, step 3 is to assess vulnerability. We have to assess vulnerability to climate change in the target area by overlapping the factors assessed in steps 1 and 2. If vulnerability differs within the target area, its spatial distribution shall be studied. We have 6 main items for vulnerability assessment. The first is future sensitivity to climate change. Second one is community-based disaster management and crisis management. The third one is disaster resilience capability of regulatory agency. Fourth one is existing and ability of research and development. Fifth one is compensation for storm surge and high wave damage. Finally, land use and land use regulation. Now, we would like to introduce a focal point to vulnerability assessment. The definition of vulnerability is here, and 4 main points I'd like to explain as focal points. The first one is location and elevation. The main point is the percentage of coastal protection facility installed in coastal area at high risk of disaster. The second one is maintenance and monitoring. That is deterioration on the repair frequency of coastal protection facilities and related facilities. The third one is the design conditions. The design condition includes application of design condition for coastal structures for future change of predicted wave heights and storm surge. The fourth one is related facilities. So coast has the various kind of related facilities such as road, port, airport in the coastal area. I'd like to explain the first focal point, that is location. Example in Japan. The location or ground elevation where coastal protection facilities are installed is critical for vulnerability assessment because huge inundation damage may occur after breaching. Here is an example of the length of coastal dike, which ensure the enough elevation of coastal dike along Japan coast where needed. The cover ratio is about 70% for whole Japan coast, and the cover ratio at coast and high water level is about 80%, and the cover ratio in front of mega cities Tokyo, Nagoya, and Osaka is about 80% too. However, the vulnerability of coastal structure under high water level and in front of megacity is more severe than those of other areas, even if the percentage of adequate elevation of coastal structure are similar. The second focal point for the vulnerability assessment for coastal protection structure is monitoring and maintenance. Once a structure is constructed, it should be subject to ongoing monitoring and maintenance to ensure that the structure remains in good condition over its design life. If adequately maintained, structure can often significantly exceed their intended design life. Conversely, the structure which are not maintained may fall prior to their intended design life. The seawall monitoring can typically be divided into 2 parts. The first is condition monitoring to assess the condition of the structure, including superficial inspections multiple times a year and reporting of defects, changes, or unusual features of the seawall, such as cracks, displacement elements, or scour. And the special inspections carried out following specific events, such as extreme events, floods, storms, or when other inspections indicate a cause for major concern. The other point is performance monitoring, focusing on the assessment of the principal function of the structure, such as limiting overtopping to tolerable levels and protecting the land and structure behind the seawall. Monitoring of the structure would typically be undertaken after large wave and high sea level conditions, or reports should be collated of such conditions. Results of monitoring may be the following 4 actions. First one is to take no action, continue monitoring when no problems are identified or issues are minor. Second one is to rehabilitate all or part of the structure where steps are taken to correct a problem before the structure functionality is significantly degraded. The third one is to repair all or part of the structure after damage has occurred and the structural functionality is significantly reduced. The fourth one is to upgrade or retrofit the structure to achieve a higher functionality or to withstand modified design conditions. This slide shows a maintenance example in Japan. The deterioration and repairing frequency of coastal protection structure affects the vulnerability of the coastal protection structure. The assessment for condition of coastal structure is regularly implemented based on the assessment manual in order to preventively manage coastal structure in Japan. About 60% of coastal dike along Japan's coast have been assessed, and 15% of coastal dike needs somehow countermeasure, that is grade A. It is critical to regularly assess the condition of coastal protection structure and understand their conditions as well as formulation of maintenance and monitoring strategies. The third focal point for the vulnerability assessment of coastal protection structure is design condition. So design conditions for coastal protection structure comprise water level, tide, wave, tsunami, current, an earthquake, and so on. Some critical forces could be affected by climate change, such as sea level rise, wave, as mentioned above. The conditions for coastal protection structure should consider the climate change effect, such as sea level rise, predicting wave height, wave period and directions, and predicting storm surge. The vulnerability of coastal protection structure would be less if design conditions with climate change effect are applied. The fourth focal point for vulnerability assessment for coastal protection structure is related facilities. The coast has critical relationship between various other related facilities, such as road, port, airport in coastal area. The vulnerability assessment should also consider these conditions based on the characteristic of related facilities, such as road environment, strength to rainfall and high temperature damage, and so on. Here is an example in Japan. The access bridge to Kansai Airport was damaged by collision of large ship that was uncontrolled by strong wind due to Typhoon 21 and 2018. We cannot use the bridge forward, which resulted in huge economic loss by closure of the airport. So we have to consider the related facilities for vulnerability assessment of coastal protection structures.